Hi again. I didn't show you the figure XP. So figure XP will take it from a millilacroid to a mirror profile. I gotta check something real quick here. It's recording. Okay. So I just worked the mirror again, and I want to know what the profile looks like. So I can do the profile on any one of those ranges. So here's range 1. By the way, this is cell S68. And I made mine purple so they're easier to find, but this is range 1, range 2, range 3, range 4, range 5, range 6, range 7, range 8, or you could just do the all ranges average, and that's what I'm going to do right now. But you can do all 8, and it's actually kind of cool, but I'm just going to do the 1. So here's a millilacroid graph, and so going from zone 7 to zone 6, you know that's climbing a hill, still climbing in a hill. This is above 0, it's climbing a hill. The hill levels out and goes down, and then the hill goes back up. So the profile is going to look something like this and like that. So it's high in the middle with a little bit of a crater around that mountain around zone 3. But let's go ahead and look at it anyway. So I'm going to start my figure XP. Click, click. Then I got to work my way to those files. So that takes about a year. Too many things to click with figure XP. Okay, so there's a file I've already got. I've got all my stuff in, so I'm just going to do my readings. Tell you what, in case you haven't done figure XP, I think you have, but in case you haven't, in setup you got 7 zones. The zones are effective. You do not want inner outer, you want effective. They're in inches. They're moving. They are not fixed. They are moving. Got my radius of curvature here. Mirror diameter, and my conic constant is -1 because it's paraboloid. And then I go down and I take those mask radii and I insert them into these 1 through 7s down here. Okay. Now from here I just plug in my data. So 0.0744. Okay, it only rounds it to 3 instead of 4. That's all right. 0.0218. 0.039 or 4. 0.089 or 6. 0.1434. 0.2112. The last one's already established, 0.2763. It's a little off there, isn't it? Weird. It usually remembers that last one for some reason. Okay, so there's my mirror profile. Now, I can move this razor positioning thing, so, wherever you want. So right here is what I described. It went up, had a little dip, and then went back up. So this is one way to look at it, but I could put the knife edge position. This acts like it's a knife edge positioning thing. So I could move my knife edge to get the smallest peak to valley, which, boink, is going to be right around there somewhere. So peak to valley on my wavefront 1.25, 1 over 1.257. Yeah, I could make that a little bit better if I get the tops there. So right there's the best peak to valley. Now, from here to here is 1/5 of a wave, because 550 nanometers is a wave, and so 100 nanometers is 1/5 of a wave. But that's the surface profile. The wavefront is twice that. So twice 1/5 of wave is 1 over 2.5 waves. So here we're at 1 over 2.71 waves. So it's about a 0.4 wave mirror when you look at it that way. Now, that doesn't mean that I'm going to wear the mirror off here and here and here. I'm going to wear the mirror off this way because I wear the mirror off the middle. So I'll wear the mirror off here and I'll wear the mirror off here and I should get there. The other thing you can do is you can maximize your Streula ratio. So if I go to that 1/2.7, whatever that was, right there, notice that my Streula ratio is 0.774. But if you readjust it so that the outer part of the mirror is as flat as you can, that Streula ratio will go up. So right now, 0.774, and I could adjust that till it gets higher, 780, 790, 800, 81, 82, 83, 84, 85, 86. So there we go. I got an 86% Streula ratio. Because if you look at the meat of the mirror, most of the surface of the mirror is this outer area out here, the inner area. Number one, this is obstructed by the secondary mirror. And number two, what's left over has very small surface area. This stuff out here has large surface area. So on the outer portions, if you get the smallest distance between the peak and the valley, you'll maximize your Streula ratio. So this is 50 nanometers. This is 18 nanometers. So it's only 22 nanometers from here to here on most of the mirror, which, by the way, is pretty good. 22 nanometers is a 20th of a wave, about a 22nd of a wave on the peak to valley of the mirror. So that's about 11th wave on the wavefront if you disinclude the middle area here. So I'm not saying my mirror's done. I'm just saying that reading this thing has a lot of different things going on. Another way I like to do is go back to the way I work a mirror. I work the mirror by wearing away in the middle. So there, pretty good. Looking situation here for wearing away the mirror, the middle of the mirror. And the height of that is a half a wave in height, which would be 1 wave in wavefront. But look at the glass remaining, 22 cubic millimeters. As I wear the glass away, the mirror gets bigger, better and better and better. That number goes down significantly. You might end up at 3 or 2, maybe even less than 1 cubic millimeter glass removed when you're all done. So the things I'll look at on this would be the peak to valley error, the glass remaining, and the Streula ratio. You can look at RMS. A lot of guys look at RMS. So my rule for finishing a mirror is the peak to valley error needs to be smaller than a 10th wave. But using the arithmetic we're doing, they'll end up way better than that, like 18th wave, 22nd wave, something like that. The Streula ratio needs to be 0.94 or higher. Well, we'll get them around 9899, 995. And the RMS needs to be, the Rayleigh criteria says the peak to valley needs to be a quarter wave. The Streula ratio needs to be a 14th wave. Mirrors can't really get any better than when you hit a 10th wave on the peak to valley, a 26th wave on the RMS, and a Streula ratio of 94%. Beyond that, you're probably never going to see anything better. So the wavefront needs to have an RMS that's at least a 26th wave or smaller. We generally get, when we take the surface RMS in nanometers, convert it to wavefront, and then convert it to waves, it's usually around an 80th of a wave, somewhere around there. But anything a 26th wave or smaller is good. So this was figure XP. Now I could have done that with any of these other 8 individual radii and map out the mirror, but I have found that gets me in trouble when I try to spot work a mirror using figure XP, so I don't do that. Now, I am going to save this last thing, so I'm just going to exit out. I can confirm my exit, and I'm going to overwrite existing file. If I just discarded changes, it would not save it. If I click overwrite existing file, it will actually save the last version of what I just did. And that is figure XP. Bill can show you how to do 6 tests.